Something fascinating is happening in our understanding of the universe. The James Webb Space Telescope, humanity's most powerful eye on the cosmos, was built to peer back to the dawn of time, to test our story of how everything came to be. But instead of just confirming the story we expected, it's finding things that are seriously challenging our models. We're not talking about one little glitch in the data. We're talking about a pattern of cosmic oddities that are forcing astronomers to rethink some of the core ideas of cosmology. These aren't just weird sightings, they're puzzle pieces from the beginning of time that don't seem to fit. Today, we're looking at three of these puzzling discoveries. A galaxy that seems far too mature for its age, a swarm of mysterious little red dots that defy easy explanation, and a wild theory that black holes might have existed before the first stars. Each one is a contender for a discovery that could rewrite our textbooks, and we're going to try and figure out which one is the biggest puzzle of all. Let's start with what should have been a pretty straightforward observation. Astronomers pointed JWST at an ancient patch of sky, hoping to see the faint first flickers of baby galaxies. Instead, they found JADE's GSZ 13-0. This isn't just any old galaxy. Its light has been traveling for over 13 billion years, so we're seeing it as it was only about 320 million years after the Big Bang. To give you some perspective, if the universe's entire history were a single calendar year, we're looking at something that showed up on January 3rd. According to our standard model of cosmology, this was a time called the Cosmic Dark Ages. The universe was filled with a thick fog of neutral hydrogen gas that should have absorbed the light from the first stars, like a cosmic curtain. This fog was supposed to clear out slowly, over hundreds of millions of years, as the combined light of many young galaxies gradually ionized the gas and made the universe transparent. But JADE's GSZ 13-0 apparently didn't get the memo. This galaxy isn't just faintly visible, it's surprisingly bright and clear. JWST detected a specific type of ultraviolet light called Lyman alpha emission. This light is famously fragile and almost always gets swallowed by that hydrogen fog. The fact that we can see it so clearly suggests this galaxy had already carved out a surprisingly large, transparent bubble in the fog around it. This is the first puzzle. Galaxies weren't expected to be this influential this early. Our leading model, called Lambda CDM, predicts that big things form slowly, as smaller structures merge and grow over time. You start small, you get bigger. But JADE's GSZ 13-0, and a few others like it, look surprisingly mature when they should have just been getting started. It's like finding a robust sapling where you only expected to see a seed beginning to sprout. For a while, this was the biggest headache for cosmologists. Is our timeline for galaxy formation off? Is the process just more efficient than we calculated? It's a serious challenge, but it still works within the known rules of physics: stars, gas, and gravity. Our next anomaly, however, suggests we might be looking at a whole different kind of object. As JWST peered deeper into the cosmic dawn, astronomers started noticing them everywhere. Tiny, compact, and very, very red objects. They've been nicknamed little red dots, and they seem to pop up around 600 million years after the Big Bang. At first, the easy explanation was that they were just young galaxies full of dust, which makes things look red. But the more they looked, the less sense that made. These dots were too compact and intensely bright to be normal galaxies. Some were so luminous they seemed to defy our understanding of how quickly a galaxy could even form stars. The mystery deepened until JWST got a huge assist from nature with an object named Able 2744 QS01. Let's call it QS01. QS01 is a classic little red dot, seen about 700 million years after the Big Bang. It just so happens to be sitting behind a massive galaxy cluster. That cluster's gravity acts like a natural magnifying glass, a phenomenon called gravitational lensing. This cosmic telescope gave JWST a magnified, super detailed look at QS01's light, and what it found was stunning. The data suggests this little red dot isn't a galaxy full of stars at all. It seems to be a swirling cloud of gas, and at its heart, a supermassive black hole weighing in at around 50 million times the mass of our Sun. Think about that for a second. This doesn't seem to be a galaxy that has a black hole. This might be a black hole that is the main event, with hardly any galaxy to speak of. Based on the models, the black hole itself could make up the vast majority of QS01's total mass. For comparison, the supermassive black hole in our own Milky Way accounts for less than 0.1% of our galaxy's mass. This discovery flips the script. The long-held assumption was that galaxies form first, and then, over billions of years, a black hole at the center slowly grows. It's the classic chicken and egg question. Which came first, the galaxy or its black hole? QS01 points to a shocking answer. At least in this case, the black hole may have come first. This has led to a radical new idea about what the little red dots are. They might be a whole new class of object some scientists are calling quasi-stars. In this model, a huge, hungry black hole is wrapped in a thick blanket of gas. The incredible energy blasted out by the black hole heats that gas, making it glow an intense red. It looks like a compact little galaxy, but it's really a naked black hole wearing a gas cloud for a disguise. This is a much bigger puzzle than an early galaxy. It suggests a completely different way to build structures in the universe, one driven by black holes instead of stars. It's what one astronomer called a potential paradigm shift in our models of galaxy formation. But even this relies on the black holes themselves forming somehow. Our third anomaly questions even that. We're about to get into the most mind-bending possibility of all. These discoveries are happening right now, with scientific papers coming out every month. If you find this as fascinating as I do, make sure to subscribe and hit that notification bell so you don't miss our next exploration of these cosmic mysteries. The black hole first model for little red dots solves one mystery, but opens up an even bigger one. Where did these enormous black holes come from so early in the universe? A 50 million solar mass black hole can't just pop into existence. The standard method, where a large star collapses and then slowly eats gas over eons, is just way too slow. This has brought a speculative but deeply compelling idea back to the forefront of cosmology: primordial black holes. This theory suggests that black holes didn't have to wait for stars to form and die. Instead, they could have formed directly from the incredibly dense, chaotic soup of energy that existed in the first second after the Big Bang. In that chaotic environment, tiny variations in density could have become so extreme that some pockets of the universe just collapsed directly into black holes, all before a single star ever ignited. These primordial black holes, or PBHs, would have been formed from the same fundamental energy of the early cosmos, but they would have been around from the very beginning. For decades, they were a theoretical curiosity. There were lots of searches and constraints, but no compelling clues, until perhaps now. The existence of objects like QS01, a huge black hole without a big parent galaxy, is the kind of thing you might expect to see if a massive PBH was the original seed. Researchers have run simulations showing that a large primordial black hole could attract gas from the early universe, forming a bright, compact object that looks just like a little red dot, while its intense radiation could prevent a large galaxy of stars from forming around it. It's a very neat explanation for what we're seeing. If this idea holds up, it could change so much. It would mean that black holes aren't just the end state of stars. They are a fundamental ingredient of the cosmos, baked in from the start. It would mean the seeds for the largest structures we see today might not have been gas clouds, but ancient black holes born from creation's fire. Some have even suggested that PBHs could be the mysterious dark matter that scientists have been searching for, though that remains a heavily debated topic. So, we have three cosmic puzzles, three discoveries that are challenging our models of the universe. Which one poses the biggest question for astrophysics? Let's review. First, we have the surprisingly mature galaxies like JWST 13-0. These present a serious challenge to the timeline of cosmic evolution. They force us to consider that galaxy formation was faster or more efficient than we thought. Our models may need a major tune-up, but the fundamental rules still apply. Then, we have the little red dots, which may be a completely new type of object powered by black holes. This is a bigger deal. It suggests that many of the objects we thought were the first galaxies might be something else entirely. This doesn't just tweak the timeline, it introduces a new lead character in the story of cosmic creation. It forces us to ask if massive black holes, not stars, were the main drivers of the early universe. But the primordial black hole theory is the real earthquake. It offers a potential origin for those little red dots, and suggests that black holes are a primordial ingredient woven into the fabric of the universe from its first second. This doesn't just challenge our model of how galaxies form, it challenges our model of the universe's beginnings. While the evidence for early galaxies is solid, and the evidence for the strange nature of the little red dots is getting stronger, the primordial black hole idea is still the most speculative. But it's also the most revolutionary. So, which is the biggest challenge? The early galaxies are a puzzle. The little red dots could be a plot twist. But the possibility of primordial black holes could rewrite the first page of our cosmic origin story. It's a ghost from the universe's past that has been hiding for 13.8 billion years. The James Webb Space Telescope wasn't built to find things that shouldn't exist. It was built to find the truth. And it might just be giving us the key to unlock a deeper, stranger, and more amazing picture of the universe than we ever imagined.